exponential functions. A little review. To convert a percent to a decimal, you move the decimal point 2 places to the left. So 20% is 0.2, 5% is 0.05, 100% is 1.00. Adding 100% to 5% gives you 105%, which is 1.05 as a decimal. Combining like terms, recall that 2x plus 3x is 5x. If you have x by itself, the coefficient of x is equal to 1, so 1x and 3x makes 4x. X plus 0.05x is 1x plus 0.05x, so that's 1.05x. If you have 100 plus 0.05 times 100, that's 1 times 100 plus 0.05 times 100, or 1.05 times 100. Rules of exponents. Remember that when you multiply exponential expressions with the same base, you add the exponents. X squared times x cubed is x to the 5th. X, which is x to the 1, times x cubed is x to the 4th. 1.05 times 1.05 is 1.05 squared. 1.05 to the 1 power times 1.05 squared is 1.05 cubed. So we're going to start with an example of a percent word problem. Part is a percent of a whole, and in this case, we're going to look at interest, which is a percent of the principal. The principal is the initial amount that's been invested. So when you invest $100 at 5% interest, the amount of interest you earn is 0.05 times 100, which is $5, and that's called simple interest. This example is compound interest. Compound interest is when you earn interest on the interest. So if your initial investment is $100 and your annual interest rate is 5%, T is the number of years. So at time 0, we have $100. 1 year later, you have $100 plus 5% of 100. So $100 plus $5 is $105. But we're going to write it like this. That's 1.05 times 100. The second year, we have $105 plus 5% of $105. Which is $110.25. That 25 cents is the interest on the interest. But we're going to simplify this as one of these plus 0.05 of these. So that's 1.05 times 1.05 times 100. 1.05 times 1.05 is 1.05 squared. Year 3, we start out with the $110.25. And we add 5% of that amount. So I have one of these plus 0.05 of these is 1.05 times 1.05 squared times 100, which is 1.05 cubed times 100. So you're probably starting to see the pattern. At the end of 1 year, you have 1.05 to the 1 times 100. After 2 years, 1.05 squared times 100. After 3 years, 1.05 cubed times 100. If we follow this pattern, after 4 years, we'll have 1.05 to the 4th times 100. After 5 years, 1.05 to the 5th. So after t years, I'll have 1.05 to the t times 100. This is an exponential function because the variable is an exponent. You'll recall a power function that has a variable in the base and the exponent is a constant. Exponential functions have a constant in the base and the variable is an exponent. Exponential functions have a constant percent rate of change. If x is the number of years and your initial value was $200 and the function paid 7% per year, then your function would be 200 times 1.07 to the x. What you want to remember is that that 1 represents 100% of the initial value, and it's being increased by 7%. That's where you get a base of 1.07. So that's 100% increased by 7% each year. If x is the number of years and the initial value is $500, you put it into an account that pays 3.5% per year, then your function will be 500 times 1.035 to the x. 1.035 is 100% plus 0.035, 3.5%. If f of x is 250 times 1.02 to the x, where x represents the number of months, what is the initial value and the percent rate of change? The initial value is 250. And this function is increasing by 2% per month. The initial value of this function is 47. And it is increasing by 8.3%. And because x is the number of weeks, that's per week. If you bought a car for $40,000 and each year the value decreases by 25%, you would think after 4 years the value would be 0. Let's look at it closer. So at time 0, it's worth $40,000. After 1 year, you have the initial amount, which is decreased by 25% of the initial amount, and that's 1 times 40,000 minus 0.25 times 40,000. So that's 1 minus 0.25 times 40,000. 1 minus 0.25 is equal to 0.75. So 75% of the initial value remains. At the beginning of the second year, that's the value of the car. And then it decreases by 25% of that amount. So we have one of these. We take away 25% of this. So that's 1 minus 0.25 times 0.75 times 40,000. But 1 minus 0.25 is equal to 0.75. So that's 0.75 times 0.75, which is 0.75 squared times 40,000. So at the end of 1 year, it's 0.75 to the 1 times 40,000. After 2 years, it's 0.75 squared times 40,000. So you can probably guess the pattern. After 3 years, the value of the car will be 0.75 cubed times 40,000. After 4 years, 0.75 to the 4th times 40,000. So for any t years, it's 0.75 to the t times 40,000. So this is an exponential function. My initial value is 40,000. And you want to remember that 100% of the initial value is part of the base of the exponential function. So this is an exponential function that loses 25% of its value per unit of x, which in this case is years. So for the following examples, what is the initial value and rate of change? F of x is 20,000 times 0.88 to the x, where x is the number of years. So the initial value is 20,000. So what is the rate of change? Well, 0.88 is 100% minus 12%. So this function is decreasing by 12% per year. For this function, x is the number of months. The initial value is 30,000. To find the rate of change, we look at the base of the exponential function. 0.65 is 100% minus what percent? Well, that would be 0.35. So this function is decreasing by 35% per year. The general form of an exponential function can be written as f of x equals a times 1 plus r to the x, where a is the initial value, r is the percent rate of change per unit of x in decimal form. If r is positive, the function is increasing. If r is between -1 and 0, the function is decreasing. Another way to write this function is a b to the x. It's just writing b instead of 1 plus r. So when r is greater than 0, b is greater than 1. So if the base is bigger than 1, it's an increasing function. When r is between -1 and 0, that means the base of the exponential function is between 0 and 1. Then it is a decreasing exponential function.